So this leads us to our two laws of thermodynamics that we're going to talk about. Our first law of thermodynamics states that energy is conserved. Okay, so this is just like the law of conservation of mass. It is neither created nor destroyed. You can't create energy. This isn't a magic like a Harry Potter. Right? There has to be a location that it comes from. Right? So like an atomic bomb, for example, that amount of energy being released into the system is due to breaking up the energy found in the nucleus of an atom, which is really holding those protons and neutrons really tight together. And when you break them open or you split them up, that energy has to go somewhere. So that's where the explosion comes from. It's an extremely vast and quick release of energy into the system. Okay, so that's our first law of thermodynamics. Our second law, this kind of gets into a term that's going to be a little confusing. Might take some time to wrap your head around it. It still does for me sometimes. I'm still trying to figure out this term. But basically, second law is that energy tends to disperse. Okay, so when something happens, that means that energy is going to kind of spread out. Okay. And this leads us to this idea of entropy. Okay, so entropy, we kind of think about disorder or randomness. So the entropy in thermodynamics, or according to the second law of thermodynamics, always increasing. We are always increasing the amount of disorder or randomness in a system. Think about when you open up or you spray out of, maybe you open up a bottle of water and you pour it or you throw it up in the air. That water isn't going to go magically back into the bottle, right? It's going to spread out. And anytime there's a reaction that releases energy, that energy isn't magically going to go back into the reactants. It goes out into the rest of the system. So the universe, or the entropy within the universe, is always kind of going up. Okay, so things are naturally becoming more dispersed and more disordered rather than becoming more collected and ordered. All right, so things don't just magically get put back together. Okay, and that kind of leads us into some of those questions that you'll see in the handout, and how basically these two laws of thermodynamics are constantly in play.